to lesson 1 of our unit on division. Today we're going to be learning to describe the properties of prime and composite numbers. Our success criteria for today is I can define what a prime number is, I can define what a composite number is, and I can identify examples of prime and composite numbers. To recap, I want you to think about what odd and even numbers are. How can we define whether a number is odd or even? And believe me, this will come in handy today. You need to remember that even numbers can be divided by 2, i.e. can be split into 2 equal groups with no remainders. Even numbers all end in 0, 2, 4, 6, and 8. Odd numbers cannot be divided by 2. That is, you can split them into 2 groups, but the groups will not be even. Odd numbers end in 1, 3, 5, 7, or 9. Today we're going to classify numbers as either prime or composite. We need to know whether a number is prime or composite when we're trying to figure out how many factors a number has. This can also help us find the lowest common or highest common factor of 2 numbers, and we're going to learn about that a little bit later in the year. Prime numbers are numbers whose factors are only 1 and the number itself. For example, 17 is a prime number because it can only be divided by 1, in 17 divided by 1 is 17, and 17, which is itself. 17 divided by 17 is 1. There are no other numbers we can divide by 17. We can divide 17 by and get a whole number answer. Composite numbers, on the other hand, are numbers which have more than 2 factors. For example, 24 is a composite number because it can be divided by 1, 24, 6, 4, 3, 8, 2, and 12. There are 8 different numbers we can divide 24 by and get a whole number answer. So it has 8 factors, which is a lot more than 2. You should be able to tell quite easily if a 2-digit number is prime or composite just from knowing your times tables. For example, is 64 a composite number? Think, is 64 in a times table that you know? Now I'm going to share some hacks with you for working out whether 3 or 4-digit numbers have more than 2 factors that they're divisible by another and by a number other than 1 and itself. Some of the basic rules. 0 and 1 are neither prime nor composite. 0 has no factors because we can't divide or multiply it. And 1 only has 1 factor, which is itself. And there's not really a word to describe that, I don't think. Any even number is composite, okay? So if you can see that it ends in 0, 2, 4, 6, or 8, it's an even number, which means it's a composite number. I did tell you that was going to come in handy today. There is only one exception though, and that exception is 2. 2 is the only even prime number. It's kind of special. Its only factors are 1 and 2, which is itself. So it has 2 factors, so it's a prime number. Some of the trickier rules. If a number ends in 5, so there's a 1 in the 5s, a 5 in the 1s column, it's also divisible by 5, which means that it's going to have more than 2 factors. If you add all the digits up in a number and the answers in the 3 times tables, it's also divisible by 3. And if you add all the digits up and the answers in the 9 times tables, it's also divisible by 9. There's some trickier rules for you. All right, guys, the first example of figuring out whether a number is prime or composite is going to be with the number 139. Now, this one isn't in any times tables that I know, so I'm going to have to use some of the tricks or some of the rules that I told you about. I know that 139 has a factor of 1 and 139. However, I need to see whether it's divisible by anything else. I think that just by looking at the last digit in the 1s column, it might be divisible by 3. So I'm going to go ahead and test that by adding up the digits to see if that number is divisible by 3. 1 plus 3 is 4, plus 3 is not, plus 9, sorry, is 13. And then I'm going to add those two digits together and I get 4, which is not divisible by 3. And I don't think that that is divisible by any of the numbers, any of the tricks that, any of the rules that I'm going through. So I'm going to say that this number is a prime number. All right, now I'm going to look at how many prime numbers there are between 0 and 20. I've written the numbers out here and we're going to go through them systematically. The first one we're going to look at is 0. 0 has no factors, so it is neither prime nor composite. The same actually goes for 1 because it only has one factor, which is 1 itself. So it's neither prime nor composite. 2 is actually a special number because it is the only even prime number. Okay, it has 2 factors, 2 and 1. The next one that we're going to look at is 3. It has 2 factors, which are 1 and 3, making it a prime number as well. I'm going to circle these primes. 4 has 3 factors because I can times 1 by 4, so there's 2. And I can also times 2 by 2 to make 4, so it's actually a composite number. 1 has 2 factors, and I can't times together any other numbers to make 5, which means that it is a prime number as well. 6 has 2 factors, as all numbers do, 1 in itself, but it also has 2 more factors, 3 and 2, making it a composite number. 7 has 2 factors, 1 and itself, and there are no other numbers that I can times together to make 7, making it also a prime number. 8 has 1 and itself, and I can also times together 2 and 4 to make 8, which means that it's a composite number. 9 is an odd number, which, and most prime number, well, all prime numbers are odd, but it has 1 and 9, and it also has 3. So it's not a prime number because it has more than 2 factors. 10 is an even number, and actually I'm going to go ahead and just cross out all the even numbers because I know that they're all also divisible by 2, which means that they have more than 2 factors. 11 has 2 factors, and there's no other numbers that I can times together to make 11, so it is prime. 13 is the same. I have 1 and 13. There are no other numbers that I can times together to make 13, so it's a prime number. 15 has 1 and itself, but I can actually times together 3 and 5 to make 15, so it's not a prime number. It has 4 factors, and prime numbers only have 2 factors. Like 17, there are no other factors of 17, so it's a prime number. And the same with 19 as well. There are no other numbers that I can times together to make 19, so it is a prime number. And there we have 1, 2, 3, 4, 5, 6, 7, 8. The first 8 prime numbers. My final example is with the number 45, and I would like to see if it is a prime or composite number. As all numbers do, it has 1 and itself as 2 factors, but does it have any more which make it a composite number? I can see that this number ends in 5, so I know it's in the 5 times table somewhere. And if I go through, 9 times 5 makes 45, which means that 9 and 5 are also factors, which means that there are more than 2 factors for 45, so it's a composite number. It also has 3 and 15 as its factors. I think that's about it. So it is a composite number. I hope that was helpful for you guys. If you'd like some further practice identifying prime numbers, there's a link on the board there. Well, let's have a look at the success criteria for the lesson. If you're looking for an extension think, how many prime numbers are there in the first 100 numbers? If you look at 100 square, see if you can figure out which ones are the prime numbers. Have we met our success criteria for today? Do you know what a prime number is? Do you know what a composite number is? Can you give me some examples of prime and composite numbers? Here are your mathletics tasks for today, guys. Grade 5s have some factors activities if they have not already been done previously, so I'm